Statics means it deals with the study of fluids when they are at rest. The absolute pressure and atmospheric pressure gives us gauge pressure at a depth h below the surface of the liquid. Thrust means the force. So what is fluid thrust? The normal force exerted by fluid on any surface in contact with it is called as fluid thrust. Hello everyone, welcome to session 1 of chapter 10, Mechanical Properties of Fluids. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. So in the previous sessions, we have discussed about mechanical properties of solids. What is a rigid body, what is deforming force, what is restoring force, and what are some applications of mechanical properties. Now in this chapter, we are going to understand what are some mechanical properties of fluids. Then what is the meaning of fluid? So let us understand what is a fluid. We all know that matter is classified into 3 states as solids, liquids and gases. How do we differentiate this solid, liquid and gases? Solid that has definite volume and shape because the molecules in solids will be tightly packed, and liquids, they do not have a definite shape but it has a definite volume. Liquids will take the shape of the container in what we place it. So it has a definite volume, it doesn't have a perfect shape. And gases, they neither have volume and nor a definite shape because the molecules of gases are fully free. In liquids, it is not tightly packed nor full free, but it is loosely packed. So it doesn't have a proper shape or a definite shape, but it has a volume. So these are the basic classification of matter. So what are fluids then? We have solids, liquids and gases, but what are fluids? Fluids are nothing but the substances that can flow. So any substances that can flow is considered as fluid. We all know that solid cannot flow, but a gases and a liquids can flow and they together called as fluids. So any substances that can flow are called as fluids. For example, gases and liquids. So here, in understanding the mechanical properties of fluids, it involves the understanding of certain basic terminologies, one of which is hydrostatics. In the previous sessions only, I have told you about what is the meaning of statics. Statics means it deals with the study of fluids when they are at rest. Now we understood what is hydrostatics. Next we are studying fluid mechanics. We know what is static. Static refers to rest position and mechanics refers to the motion. So fluid mechanics nothing but it deals with the properties of fluids when they are in motion. So now we understood what is hydrostatics and fluid mechanics. Let us understand one more important terminology, that is fluid thrust. What is a thrust? Well, if we understand what thrust means, then we can easily define what is fluid thrust. Thrust is nothing but the force. Thrust means the force. So what is fluid thrust? The normal force exerted by fluid on any surface in contact with it is called as fluid thrust. For example, look at this image. So here this surface is in contact with the fluid. This is the normal force exerted by the fluid on the surface of contact of any other substance, and that normal force is called as fluid thrust. As I said, thrust means a force. So the thrust per unit area, which is nothing but the force exerted by the fluid. Fluid thrust means the force exerted by the fluid. So fluid thrust per unit area is called as fluid pressure, because we know pressure is equal to force divided by area. Here, what force we are talking about? It is the force exerted by the fluid on the surface of a substance. So this force exerted by the fluid is called as fluid thrust. So fluid thrust per unit area gives us fluid pressure. So the SI unit of pressure is Pascal, or we can also write it as Newton per meter square, because we know the SI unit of force is Newton and the unit of area is meter square. So SI unit of pressure is Newton per meter square, or we can also consider Pascal. So while writing the symbol, P must be capital. It is so important to remember. Now let us understand what is density. So far we have learnt hydrostatics, fluid mechanics, fluid thrust, fluid pressure. Let us now understand what is the meaning of density. So density is nothing but the ratio of mass of the body to its volume. Density is generally denoted by the symbol rho, and this is called as rho. It is nothing but the ratio of mass of any body to its volume. So what is the SI unit of density? What is the SI unit of mass? It is kg. The unit of volume is meter cube. So when this goes to numerator, we will get kg per meter cube is the SI unit of density. Either you can write slash or you can write it as m to the power minus 3. But you should not use both. So kg per meter cube is the SI unit of density. The density of water is 1000 kg per meter cube. So in the study of fluid mechanics, an ideal fluid what we consider is water, since it is very much familiar and also it is very easy to understand the characteristics. So the density of water is 1000 kg per meter cube. Now we got to know what is density. Let us now understand relative density. So what is relative density? How it is defined? The relative density of the substance is the ratio of the density of the substance to the density of water. So if you want to check the relative density of any material, you have to take the ratio of the density of that substance to the density of water. So that is how you have to find the relative density of any substance. I repeat, the relative density of any substance can be obtained or can be determined by taking the ratio of density of that substance divided by density of water. As we all know, density of water is 1000. So what we have to do is we have to calculate the density of substance. What we have to find the relative density. Then we have to take the ratio of these two values. We will get the relative density of particular substance. So easily you can understand that the ratio of density of substance divided by density of water gives that relative density. So next, what is pressure? Pressure is very much familiar to all of us since we are discussing this from the first unit. It is defined as normal force per unit area or fluid thrust per unit area, because fluid thrust is nothing but the normal force exerted by the fluid. So it can be given as P is equal to F by A, and the SI unit for pressure is Newton per meter square or Pascal. Next important point what we have to understand in the study of mechanical properties of fluids is atmospheric pressure. So generally atmospheric pressure is nothing but the pressure exerted by the atmosphere, or it can also be defined as by taking the mercury into consideration. So how this pressure or the atmospheric pressure can be calculated? What is the device which is used to measure the atmospheric pressure? All these things we have to know. The atmospheric pressure is nothing but the pressure exerted by the height of mercury column of 0.76 meter at sea level at 0 degrees Celsius. So this is how we define the atmospheric pressure, or it can also be defined as the pressure exerted by the atmosphere. To understand what is atmospheric pressure, we consider it is nothing but the pressure exerted by the atmosphere. We have to define like the pressure exerted by the vertical column of mercury of 0.76 meter at 0 degrees Celsius at sea level. Now, how to measure this atmospheric pressure? What is the device used to measure this atmospheric pressure? So, the device used to measure the atmospheric pressure is called as barometer. It is also called as mercury barometer, but generally it is a barometer. So, it's a very important question. The device used to measure the atmospheric pressure is barometer, and one atmospheric pressure can be calculated as P is equal to rho GH. Rho is nothing but the density. Density of what? We have considered mercury. And G is acceleration due to gravity. H is the height of liquid column. As I told, it is 0.76 meter height of mercury column at 0 degrees Celsius. So let us now substitute all the values. The density of mercury is 13,596 into G value is 9.8. H value is 0.76. So multiplying all these, we will get the value of one atmospheric pressure is the 1.013 into 10 power 5 Newton per meter square. Since we are calculating pressure, the unit is Newton per meter square, and this is a standard value of one atmospheric pressure, and which we are going to use in many upcoming derivations or numerical problems. So one atmospheric pressure can also be written as 1.013 into 10 power 5 can be written as 101.3 kilopascal. Because kilo is 10 power 3 and shifting the other two digits, the decimal to next two digits, we will get 101.3 kilopascal. Thus, atmospheric pressure decreases as the height from the surface increases. As we go above and above and above, the atmospheric pressure is going to decrease. So, this is the value of atmospheric pressure you have to remember. So, let us now go for one derivation that is very important. Pressure due to a liquid column of height h, which means we have considered a liquid column of height h. What is the pressure due to that liquid column which is confined in a container? We are going to derive the expression for pressure due to liquid. So, let us now see how to derive it. Consider a liquid column of height h and area of cross section A. Here we have considered a container and inside that we have liquid. So, the liquid of height h and which is having the area of cross section A. So, the rho be the density of a liquid. We know the liquid will have density and density is denoted by the letter rho. This is not P, this is rho. This is rho, the symbol of density. So, density be rho of the liquid. Pressure at the bottom due to liquid is given by. So, how to define the pressure now? See, we have a liquid here. So, this liquid will exert some pressure to the bottom. So, we have to find what is the pressure here due to the liquid. So, that can be given by F by A because we know it is fluid thrust per unit area. Fluid thrust is nothing but the force exerted by fluid. So, P is equal to F by A and call it as equation 1. So, here F is nothing but the weight of the liquid column. Force exerted by the liquid column is nothing but, here we have to find the pressure, which means this is the weight of the liquid which is creating the pressure. So, here we will consider F as W, that is nothing but weight of the liquid column. Because due to the weight of the liquid, the force is exerting at the bottom. So, we will consider as W. So, now F is equal to mg. So, what is F is equal to mg? Force is equal to mass into acceleration. Here the acceleration is acceleration due to gravity. So, m is the mass of the liquid column and g is acceleration due to gravity. We know that F is equal to rho v into g. Why it is rho v into g? Because we know mass is equal to density into volume. How it is? Because we know what is the definition of density. It is mass per unit volume. I have explained this in the beginning. So, rho is nothing but density, which is nothing but the ratio of mass by volume. We need mass. So, it will get multiplied. So, rho into V. That is nothing but rho V. So, in the place of M, we can substitute rho V into G. That is F. Now, F is equal to rho. V can be replaced as A into H because we know volume is nothing but length into breadth into height. But what is length into breadth? It is nothing but area. So, we can write it as V is equal to A into H. So, this is replaced in the place of V. That can be written as F is equal to rho, V is written as AH and G as it is retained. Next, putting this in the equation 1. What is our equation 1? P is equal to F by A. But what F is? F is nothing but rho A H G and in the denominator also we have A and this A and A will get cancelled and we will get P is equal to rho G H. So, the pressure due to a liquid column is given by rho G H where rho is the density of the liquid and G is the acceleration due to gravity and H is the height. So, this is called as hydrostatic pressure at a point which is at a depth of H from the surface of liquid, which means here we have found the pressure. So, hydrostatic pressure because of the liquid of height h from the surface and that is given by P is equal to rho G H. From this expression, we can say that what are the factors on which the pressure at a point in a liquid depends on. Now, look at the terms and we will define what are the factors on which the pressure depends. So, it depends on density of a liquid because we have rho and it also depends on acceleration due to gravity, that is G. It also depends on the depth of the point, how high the point is from the surface of the liquid. So, it depends on all these factors, that is density, acceleration due to gravity and the depth. This is the expression for the pressure due to a liquid column. So, let us now understand another important derivation with the help of this, that is the pressure at a point inside a liquid. It is not at a depth or at the bottom. We are now going to calculate the pressure at any point inside the liquid. How to understand this? Consider a fluid of density rho at rest and open to the atmosphere as shown in the figure. Look at the figure. It is open vessel, open container which is open to the atmosphere. So we have considered a liquid of density rho, and the height of the liquid column is nothing but h. So assume that rho is constant. Let us assume that the density of the liquid what we considered is constant. So consider a cylindrical column of height h and area of cross section A. Here P1 is the pressure at the top of the column. You can see here we have a cylinder again. Here this is the cross sectional area. We are exerting force to the cross sectional area A, that is force by area, which is nothing but the pressure P, and I have taken it as P1 because at top surface we are now talking about. So let P1 is the pressure at the top of the liquid column and P2 is the pressure at the bottom. Here also the liquid is exerting force on the surface of this cylindrical column, which means the liquid will or the fluid will exert the force on any surface which is in contact with it. So this surface is also in contact with the fluid, and again here also the force is exerted by the fluid at this cross sectional area. So the force is exerting to the cross sectional area will give us the pressure, and for convention let us take it as P2. So P1 is the pressure at the top surface, P2 is the pressure at the bottom surface. Now force on the top of the column by the outside fluid is given by F is equal to P1 into A. So what is the force here we can define? We have F1 is equal to P1 into A. Because we know pressure is nothing but force divided by area, we need force at the top surface. So this will get multiplied. So we can define F1 is equal to P1A. The force at the top surface is always downwards. Now next, force on the bottom is nothing but the upward direction. It is in the upward direction because for bottom the fluid is acting or exerting force in the upward direction, and F2 is equal to P2A. The direction of force exerted by the fluid is upwards at the bottom surface. Now the liquid column is having certain weight, and that can be defined as W is equal to mg. Here the downward force which is acting, that means the fluid is exerting force, that is because of the weight, and it is downwards, where m is mass of the liquid in the column, and since the column is at rest, the net downward force is equal to net upward force. Here the force is not exerted only in the top surface, it is also exerted at the bottom surface. So here the fluid we have considered is at rest and the cylindrical column is also balanced. So the net upward force which is equal to net downward force. So it is equal. So the force exerted at the top surface is force exerted by the fluid plus the weight of the liquid, that is F1 plus W, which is equivalent to the downward force. So that is F2. Now F1 is nothing but P1A, weight is mg, which is equal to P2A. So here m is mass. Mass is nothing but the product of density and volume, because we know density is equal to mass by volume, and mass, if you want, means it is nothing but the product of density and volume. So mass is equal to density and volume. So density is given by rho and volume, as I explained, can be written as A into H. So let us put this in equation 1. So let us see what do we get. It is P1 into A plus rho A Hg, which is equal to P2A. So we have A on both the sides. We can take A here common and cancel. So after cancelling we get, so how to cancel? It is P1 plus rho Hg, and A I have taken common here, which is equal to P2A. Now we can cancel these two and we remain with P1 plus rho Hg, which is equal to P2. Or we can also write it as P2 is equal to P1 plus rho GH or rho Hg. That is our equation 2. Now if point 1 is at the top surface of the liquid, then P1 is equal to PA. We are talking about the pressure here, point 1. If this point which is at the top surface of the liquid, if the point 1 was here, then it means atmospheric pressure will also exert a force. So this P1 is nothing but the atmospheric pressure if the point 1 will be at the top surface or at the surface of the liquid. So P1 is equal to PA, that is nothing but atmospheric pressure, and P2 will be P, just a pressure. Here if if this is at the surface, then the pressure exerted here is the atmospheric pressure. So for convention, we can take it as PA, that is atmospheric pressure, and this point would be just the pressure exerted by the fluid, and it would be P. So P2 is equal to P. Now this equation will be modified according to now our assumption. So that is P2 will be just P as I said. So P1 will be PA plus rho Hg. So this is the absolute pressure at depth H below the surface of the liquid. Now, if you take this difference, you can also write this equation as P minus PA is equal to rho Hg. Just taking PA to the other side, we can write PA minus PA is equal to rho Hg, and that is called as gauge pressure. The absolute pressure and atmospheric pressure gives us gauge pressure at a depth H below the surface of the liquid. Now, how to determine this gauge pressure? What is the device used to measure this gauge pressure is open tube manometer. With the help of this device, we can get the difference between the absolute pressure and the pressure exerted by the atmosphere, that is atmospheric pressure. So, if we take the difference in actual pressure inside the liquid and atmospheric pressure, we will get the gauge pressure. Can be measured by using a device called open tube manometer. So the expression for pressure inside a liquid is given by P is equal to PA plus rho GH, where PA is atmospheric pressure, rho is density of a liquid, G is acceleration due to gravity, and H is the height of liquid column. This is one of the important derivations in mechanical properties of fluids, that is to calculate the pressure inside a liquid column. So in today's session, we have discussed about so many interesting concepts that we have understood what is hydrostatics, what is fluid mechanics, what is fluid thrust, what is fluid pressure and density, and we have learned how to derive the expression to find the pressure at bottom of a surface as well as inside the liquid. In the next session, we will come up with some more interesting concepts. Until then, all of you please take care. Thank you.